Please welcome Vice President, Kubernetes, AWS, Barry Cooks.
Hi, thank you all for joining me. You can stretch a little bit. I know it's the end of a long day for a lot of you. Welcome. Thank you for joining us at our very first Kubernetes leadership session, and welcome to reInvent 2022. Quick personal shout out just to all of the AWS Kubernetes teams. Thank you for your hard work. I have the easy job. I just get to represent all the stuff they get to do. So shout out to them and thanks. My guess is if you're here, you're in one of a couple of different camps. Camp number one is you already know Kubernetes. Maybe you're a current customer of ours. Maybe you're a partner. You just kind of want to know, what are you up to? Are you solving the problems that I have? What's my laundry list look like? Where are you going next? Or you just can't seem to get away from Kubernetes because it seems to be popping up everywhere. You go to LinkedIn, you go to different places, and everybody seems to have something to say about Kubernetes on their profiles. In either of those cases, my goal today is to spend the next hour really helping you walk away with an understanding of why we think Kubernetes is awesome and why we think that AWS is the best and most trusted place to run your Kubernetes workloads. So, when you look at this image, I think we can all recognize pretty quickly it has absolutely nothing to do with Kubernetes. But what I wanted to do is start off with a bit of an analogy. Let's ease our way into the technical stuff since Kubernetes is supposedly hard. I was thinking Mirage in the desert, journey to the cloud, easy to start, hard to finish, challenging to get yourself to where you want to be, right? That's sort of the general theme. My only problem is, I'm a little old school, did some searches for a Mirage in the desert, and I turned up the Mirage, which is technically in the desert. At this point, I was feeling slightly frustrated. One of the folks on the team came up and said, what's with all the chuggy image search stuff you're doing? Like, there are AI image generators these days. You should just be using one of those. And so that was how I did get to the actual Mirage in the desert. Only problem is I believe that's a Mitsubishi Mirage, but it is technically in the desert, so I was making some progress. But what's the takeaway, right? The key here is filling in these gaps from where you are today to a modern architecture. That can be really challenging. It can be a steep climb for a lot of teams, right? So the longer you've been working on-prem, the longer you've been kind of in a monolithic style architecture, the harder this path feels like. So hopefully today we'll be able to bust through some of that, help people understand what that path can look like. Let's take a quick look at the journey. Where are we going to go? What are we planning to do today? I think we'll set the stage a little bit around app modernization, a little bit on the technologies that are in use there, kind of what that path looks like. We'll talk about our customers at AWS. Why are they choosing Kubernetes? Who are these customers? What are the kinds of things they build on AWS? And it'll be a pretty broad cross-section there. We'll talk about what we've been up to with respect to Kubernetes. Like I said, for those folks who are familiar with Kubernetes and maybe they're currently using it either at AWS or somewhere else, we want to make sure we touch on those topics, talk about what we're working on, what our vision for the future kind of looks like. And I want to end it on a little bit on how to get yourself moving. So if you need a little help in that journey, what are the things that we have to help you kind of get down that path? So let's start with the problem, right? The problem is really well represented here. People are really just struggling to get the best leverage from technology that they can. And I thought this was a super interesting stat, 80-20 rule, but not in the way you'd like it. And you know, if you think about it, Gartner estimates somewhere in the neighborhood of 95% of net new workloads will be built using cloud-native technologies. That is awesome, as long as you're doing net new workloads. And if you've got this large collection of stuff that's still hanging around and has been for a long time, then what are you supposed to do? How do you kind of get yourself into a more modern architecture, using more modern technologies, feeling like you've kind of gotten to some of those gains that the cloud is always promising? This will seem pretty straightforward. Lots of commonality in what customers are asking for when they talk to us about the things they want to solve for. Should be no surprise, people want to get to market faster, right? They want lower total cost of ownership. They just want to pay for what they use and only use what they need, right? It's one of the huge benefits of the cloud, of course. They want to scale as needed for the unexpected, up and down, right? To reduce those costs, you want to be able to scale down. And if you really think about it, you want to take full advantage of the different aspects of the cloud, performance and scale being one of those. And if you take a half a step back, remember, I'll say in the old days, for classical on-prem, do you want to manage air conditioners, power suppliers, backup generators? There's all these things that people are used to not managing once they move to the cloud that are undifferentiated heavy lifts for people who are trying to get themselves out of that 80% and into more of the 20%, right? Driving that innovation engine is a big thing. The other piece related to this, security and isolation by design. The current threat landscape is very dynamic. It involves a lot of players with a lot of money who are pushing things forward. It'd be really nice to have a partner in that, and that's something that AWS is focused on since its very beginning, is security and isolation by design. And so it's nice for us to have your back on those sorts of things. So what is innovation really about? Classic flywheel. What do you want to do? You want to take an idea and get it in an experiment in front of customers as fast as you can. Whether those are internal customers or external customers, it doesn't matter. The idea is the same. I want to be able to go and test something, get real feedback, and then iterate. And the faster you can iterate, the faster you're going to get to the right kind of solution for the problem that you have, right? Nobody is perfect on Rev 1, right? So the idea is make small changes, do those incremental changes, work with your customers and get their feedback. They will see the value in you trying to meet their needs, and you will feel like you're actually moving that ball forward much, much faster and more effectively. So let's review a couple of the technologies in play for app modernization and modern cloud architectures. One of them is clearly containers, right? So what makes containers special? Why is it that both developers and IT orgs look at these and find them really valuable? So one is portability, right? The classic "it worked on my laptop" problem. One of the great things about containers is it's self-contained, pun intended. And you see in there, I've got everything I need to go run this piece of code. And when I put it somewhere else, it has everything it needs to run just like it did where I had it before. It's an amazing piece of functionality that comes with containers. From an infrastructure efficiency perspective, they're really light, right? It's easy to start up and stop containers. It's easy to pack them in, right? So you get a tighter bin packing and more efficient use of the resources that you have. So there's a bunch of strength in containers in those regards. Another thing from an operations perspective, it's back to what is undifferentiated heavy lifting and where do you want to spend your time? Do you want to manage OS images? Because there's a lot of work involved in that. Containers allow you to kind of take another half step back from that. Focus on managing your application, your content in your container, and not the rest of the components in that stack. And so it drives a savings from an operational perspective as well. If we look at Kubernetes, what made Kubernetes successful? I'll just declare now, I think it's been very successful. So when you start moving into containers, you start building microservice-based architectures. You start getting a lot of containers. And so when you get enough of them, you get sprawl, right? Somehow you need to orchestrate all of these containers and you need to drive consistent deployment mechanisms for those containers. That's where Kubernetes came to the forefront. One of the key facets of Kubernetes, ease, right? I can go and have a declarative model that gets reconciled. I can tell the system, this is how I want this set of containers to behave. This is the scaling I want for them. And the system monitors and keeps track of and continues to reconcile changes in that behavior for you over time. It's a very powerful piece of the model. Consistency, another major component when you look at Kubernetes is the API consistency regardless of where you're running Kubernetes. One of the strengths of Kubernetes, open source. That API, if I'm running Kubernetes on-prem, maybe you're running Kubernetes yourself in EC2, maybe you're using one of the products like EKS or EKS Anywhere, you have the same Kubernetes. The API is the same in all these places. It's still Kubernetes, right? And that's another powerful way for you to have teams with similar functions and similar leverage points. From an ecosystem perspective, it's a rich ecosystem. If you look at the CNCF Cloud Map, and you'll see it in one of the slides here in just a little bit, lots and lots of available innovation from lots of different companies gives you maximum choice. You can take full advantage of that. From a community perspective, with regard to the enterprise and customers in the enterprise, it's nice to have a collection of people using the same sets of technology, driving enterprise perspectives, because let's face it, the enterprise is a little unique when compared to just native open source and people who are playing around with technology. The enterprise drives certain behaviors. There's a lot of enterprises on Kubernetes driving behaviors that support other enterprises on Kubernetes. So you can take full advantage of this community to really leverage and maximize that benefit across a shared set of folks, and that's by definition the community. So we've talked a little about containers, we talked a little about Kubernetes. Now that we've set the stage, why would you pick AWS for Kubernetes? I'll say way back in 2017, because pretty much anything pre-COVID feels like forever ago at this point. Way back in 2017, when the team was first starting out on Kubernetes, we had to set up some principles. And one of those first pieces of these principles, the first two on this list, were incredibly important decisions we made. Security, job zero at AWS. There's no bypassing that ever, right? That was a clear one for us. But the second one's really important. We wanted to build a Kubernetes solution that provided value to customers, and value to customers means enterprise grade. It needs to be ready to run production workloads from a scale perspective, from an availability perspective, from a just basic perspective of how it's supported when things aren't going the way you expect. How do we support versions, right? There's a whole host of things that come into what does it mean to be production built and ready for enterprise workloads. Another piece that was a really important factor in how these principles laid out was we also wanted to be able to support native AWS services. We recognize that a lot of customers coming to AWS want to take advantage of the services we provide. They want to be able to go into that rich set of services AWS has, pick the ones that are most valuable to their use cases or for the applications to support, and leverage those. So a lot of work went into that. And then the last two are back around this open source theme. Native and upstream. We didn't want to muck with something that worked. We wanted to drive that consistent API and keep it for use by our community in the same way that it's used outside of AWS. What I like to talk to the team about is the K in EKS is Kubernetes. It's not just us. It's bigger than us. It's a community, and we have to respect it and support it. And so we've been putting a lot of effort into supporting that community, both through our own contributions, both in dollars and in code, right? And by representing our customers' interests to the community from an enterprise perspective. These are all very valuable components of our efforts as we move forward. Let's jump into them just a little bit. So when we talk about security and built for production, one of the things that we do for that control plane, we're always patching for you automatically. If there's a CVE, even under embargo, we will get you a patch seamlessly. And that's an important facet, especially, like I said, in this kind of threat environment that we're in today. We support 4 versions of Kubernetes. Any given time, we follow upstream, but even if upstream deprecates a version, we will continue to patch and support that version for you. And that's really important because as fast as open source loves to move, I'll tell you, the enterprise does not enjoy moving quite that fast, or at least not all the time. It can be kind of challenging to move workloads. If you've got 7,000 applications running in Kubernetes and you're worried about moving forward versions, it's a daunting task to look at that, right? And we're working hard to make that seamless for you. Automatic upgrades of worker nodes and the control plane. We also auto-scale that control plane for you. If your workload is increasing, we will scale up the control plane to meet that need. Those are important factors in here. Another thing is region spanning, highly available architecture. We split your control plane across 3 AZs in all cases, so that if there is an AZ outage, we will maintain your control plane viability. We're also working hard on static stability. If you suffer a control plane outage, guess what? Your application's just fine. Your workload is still running. You can't go create a new cluster, but your workload's running, right? So we will reduce your likelihood of suffering downtime through our static stability mechanisms. Those are really important facets for what we do. Clearly, we have 24/7 operations. We want to support anything that goes wrong. We're constantly monitoring your clusters to ensure that they're being successful. Everyone at AWS carries a pager. That includes me. Something goes wrong, I will get paged. That is how we support our customers. We want to be there 24/7. So we're trying really hard to take that 80% burden and drop that number, right? We want to get you down to focusing more on your own innovation. Take some of these other things off the table for you. Seamless cloud integrations, I mentioned this a little bit. There's kind of a few different categories. There's EKS, I can spin up a cluster, great, I've got myself started. But there's more than just spinning up a cluster. There's a lot of components that go into actually delivering applications to your customers. There's a set of infrastructure services, EC2, obvious example, right, that people want to take advantage of. Key management store, identity and access management, these are sorts of infrastructure level services. There's supporting services, maybe you need a queuing system for your application or you need a database. We want to make those available in an easy and consumable way. And there's higher level services. Amazon EMR is a good example. GuardDuty is another example of a higher level service that a lot of customers want to take advantage of in their Kubernetes suite. Those are things that we want to provide access to. I mentioned this before, and I'll bring it up. This is that cloud map I was talking about. So for us, it's really important that we maintain native and upstream compatibility. So we are always going to maintain this. It's super important to us that if you see something in the Kubernetes ecosystem and you want to run it, go ahead. We're super happy that you're doing that. We want to let you have that level of choice. We want to let you run the applications that you're most interested in running. If you're interested in us providing one of these as a managed service, talk to us about it. We love to hear back from customers on things that they would like us to take on as a managed service. But if it works on Kubernetes, it will work on our EKS ecosystem. From an open source perspective, a few of the things that we're up to, I mentioned code. A number of our projects now we've started. We'll talk a little about Carpenter later. Carpenter's a good example, though, built in the open. We're trying to do more of that kind of activity. We want to engage with customers who are interested in not just seeing open source and being a part of open source, but they want to contribute as well, and we want to support that kind of behavior. We do a lot of testing. We're doing quite a bit of security work for the community where we are actually doing find and fix efforts to look for security vulnerabilities in common open source code and then provide fixes upstream. So we have a lot of effort in these spaces. I've listed just a few of the places that we're actually doing significant contributions and work today, and there's many more behind the scenes on this as well. We're also supportive of the CNCF, a member of number of SIGs, we're on the board. We feel like the open source community is the right place for Kubernetes to continue to evolve. So let's take a deeper look, right? How we give Kubernetes to customers. So our goal, we want to provide it to how you want it and where you need to run it. And there's a whole spectrum of capabilities here that we work to meet. On the classical side, if you will, there's AWS regions running EKS in a region. But let's assume for a moment that you need low latency connectivity into your customers. Maybe you're doing online gaming, which is a classic example of a need for a low latency connection in a metropolitan region, because there's lots of kids that live in metropolitan regions that game. AWS local zones. Great way to run Kubernetes in the local zone. Still, EKS, still supported there. You can go out into wavelength. Let's assume that you need to get closer to a cell tower to capture incoming workloads from IoT. AWS wavelength, you can run Kubernetes there. Then let's assume you're in the earlier phases of your journey to the cloud. You're on-prem. I think for those who are here in the room, many of you may have seen the Amazon Outposts that we had out in the hallway. Outposts are supported with EKS. So on-prem, but running a cloud-connected Kubernetes. And we also now support disconnected mode for those outposts. So if you're running them in a manufacturing facility and somebody's doing construction and cuts the fiber line, which in talking to a lot of customers happens a surprisingly large amount of the time, you can be disconnected for 7 days and not have to worry. So that's plenty of time typically to fix a fiber cable. Let's assume now you don't want to invest in additional on-prem assets of any form. Your hope is to get off that, get into the cloud, but you're not there yet. You've got data center footprint, let's say 5-year depreciation schedule, you've got 2-year-old hardware. You still want to leverage that, right? You don't want to be throwing that away. It's an expensive move. So we support customer infrastructure with EKS Anywhere. This allows you to go and run Kubernetes workloads on-prem, start your modernization journey, start down this path, but do so in an EKS environment. Those are disconnect supported use cases. You can be completely air-gapped, manage that yourself. When you jump into EKS and you look at it a little bit more deeply, we have a breadth of offering here and it's continually growing. We do support bare metal. You've got your servers there, you want to just go run this. You saw Tinkerbell was on one of the slides. That's a piece of bare metal provisioning work that we've been very focused on in the open source community to support deploying EKS and bare metal. We support VMware and CloudStack for VM environments. We're in preview with Nutanix for hyperconverged environments. Hopefully that'll be GA actually pretty soon. At the bottom tier, we support multiple OS offerings. The sort of classical cases, for those not familiar with BottleRocket is a purpose-built container OS. It is built just for running container systems. Nice security posture to take with BottleRocket. That's part of the reason that we went down that path. So, another big factor in why people choose to run their Kubernetes workloads on AWS is our reach. If you look at AWS's cloud, it spans 96 availability zones, 30 different geographic regions around the world. I updated this slide, I kid you not, 3 times while drafting this deck because we're constantly rolling out new ones. We've in fact announced plans for 15 additional availability zones, 5 more AWS regions for Australia, Canada, Israel, New Zealand, and Thailand. So we're constantly evolving that ecosystem. We have more regions with 3 or more availability zones to give you a high availability solution, more points of presence at the edge locations for delivering those low latency applications we were talking about than any other major cloud provider. Right now, this slide's accurate. I suspect it'll be out of date pretty quickly, like super quickly. So keep an eye out on those. And then if you think about it, if you weren't in this mode and you're off managing those air conditioners and the data center power and all these components, and a customer reached out to you and said, I've got a great opportunity for you, but I need you to be in this location because I have latency requirements, or I have data locality requirements, super common these days, right? It's not just about GDPR anymore, right? Lots of countries have specific data requirements that are coming online. This reach will let you get there, right? This reach will let you get there in hours as you deploy new workloads into those clusters in these regions. And that's one of the powerful statements that you can really make to your customers through the global reach of AWS. So generally speaking, we don't like flexing. I only put one slide in where I'm just going to briefly do it. But the fact that we listen to our customers and that we drive these kinds of behaviors from their asks is the reason that 2/3 of containers running the cloud are running on AWS today. And that's a big statement enforced by listening to customers, solving their problems, meeting them where they're at. What are those customers doing? Let's talk for a couple of minutes about the what. Everything is kind of the short answer. It's a really broad spectrum of different kinds of applications that are being built on top of EKS. I think an easy way to think of it is maybe to put it into some context. It's everything from airline ticketing systems, video games I've mentioned, streaming television shows and movies, ride-hailing services, self-driving cars, lots of things that are interesting in these spaces. A lot of analytics and data-intensive workloads have come online in the last year or two. And I think it's probably worth taking a quick pass at a couple of examples. Riot Games is a good one. So this is a classic example. I talked about low latency needs. I talked about global reach. I think Riot is based out in Los Angeles, California, not too far from where I live. Typically, they need no introduction. Most people have heard of them. If you have a teenager who loves to game, and I do, you definitely know who Riot is because you've probably heard from them or seen them playing these various games. They have been in the development publishing business for quite some time. They have some super popular games, League of Legends, Valorant is another example, no logo there. They have customers across the globe. They need to burst their sizes based on the popularity of games at any given time. And that actually is a surprisingly complicated set of problems that they need to go out and solve. They're using EKS across many of our regions to support, at the moment, 14 million monthly active players on Valorant alone. In the AI/ML space, Aurora was founded back in 2017 by some of the industry's top veterans in self-driving. They've built a platform on top of EKS. Their flagship product is called Aurora Driver. It's a self-driving platform. It brings together a whole collection of different people in their organization, both from a software perspective, a hardware perspective, a lot of data sciences and data services activities to build self-driving capabilities for a whole set of different vehicle classes. This is no small task. It requires a tremendous amount of compute capabilities. These things are doing machine learning workloads, computer vision workloads, lots of simulations, as you can imagine. You don't want to trust a car to drive itself unless you had a lot of simulation hours behind it. So Aurora has been building their system that today spans up to 10 million tasks a day. They're working hard right now to get that thing north of 1 billion tasks a day. And this is back-ended in the EKS world. Financial services. We are super lucky, I think, as an organization. We have a lot of partners in the financial industry, excellent people to work with. If you've been to reInvent in the past, you may have heard Fidelity. They've talked several times in the past about their sort of journey that they've been on with EKS, very early adopter. Fidelity's been around for a long time, 70 years that they've been around. A lot of people think financial software is all boring. I can assure you it is not. There's some really cutting edge work that folks at Fidelity have been doing. They have been at the bleeding edge of both EKS and Kubernetes for years now, driving these workloads. They have 15,000 technologists working inside of Fidelity. It is a very large, very complicated organization, and the goal that that team had was to have them build in a modern way, doing POCs, rapidly innovating, trying out new ideas, meeting their internal and external customers, and on top of that, driving billions of dollars in transactions through their back-end systems. So if you haven't seen those folks, they are Amar and his team, very impressive set of folks, a lot of deep technology experience over the years with EKS. Expedia Group is another name that probably needs no introduction. A lot of people have heard of Expedia Group. I think one of the things that we hear a lot from enterprises is standardization. They want to have a standard way of doing things. It's kind of a constant refresh in the enterprise, in fact. And EKS has been a big point of leverage for the Expedia Group team in this space. So a lot of people know Expedia as a name. What you may not realize is they have a lot of underlying technologies. Hotels.com is one of those. There's a whole host, in fact, of different technology companies under the covers. If you go down that path, both organic and inorganic and growth, you end up with lots of different ways of doing very similar, if not the same thing. And so driving that commonality is one of the things that the Expedia Group team has been doing. As you can see, they've got 9,000 applications lined up for migration to this new platform. And RCP is not the Royal Canadian Police, just to be clear. But they've been working hard on building out this platform and migrating on to EKS. So it's one thing for me to talk about it, babble about a few customers. I think the easiest way to really see this in its true detail is to talk to an actual customer. So at this point, I'd like to welcome Sharmila Ramar to the stage. She's going to take you through the journey that she's been going through at MassMutual, exactly where they're at, and some of their interesting learnings. Sharmila?
Thank you, Barry, for inviting me to join the stage with you today. Good evening, everyone. I'm Sharmila Ramar, Head of Cloud and DevOps Engineering at MassMutual. I'm super excited to be here to share our AWS Cloud journey. MassMutual, we are a 170-year-old company and one of the largest US insurers. Our company has been continually guided by one consistent purpose. We help people secure their future and protect the ones they love. MassMutual offers multiple financial products, including insurance, life insurance plans, annuities, disability income, long-term care insurance plans, investment solutions, and above all, some of the institutional plans. We do offer a wide array of products that provides protection, accumulation, wealth management, retirement services, and products to fulfill our vision of enabling and providing financial well-being for all Americans. So with that, let's talk about our journey in the AWS cloud space. We started our cloud journey in 2015 with the idea of using innovation and cloud-native services to solve some of our constantly evolving and changing business needs. Some of our early adopters are digital experience team and data science teams. The data science and data engineering teams in MassMutual, they started building enterprise data analytics platform using cloud-native services in AWS as a replacement for some of our legacy data warehouse products. This particular experiment showed us the path to achieve our goals of reducing the cost with increased operational efficiencies and complete security. This helps accelerate our pace of data reporting and analytics, which in turn helps with the launch of new business capabilities for all lines of our businesses. We slowly evolved to use this approach to move into the cloud space as a getaway from our bespoke on-premise data center private cloud solutions to support our data center exit strategy and also the digital transformation journey. So MassMutual has been in the digital transformation journey for about 8 years, and we use technology as an enabler to solve some of our customer needs and improve our client experiences to be more efficient and speed the development of new business product solutions and capabilities. A key underpinning of our digital transformation is to simplify and modernize. This includes platform consolidation, decommissioning of legacy systems, migrating our policies to a more modern digital enabled platform, migrating our products and applications into the cloud space, enabling data streaming, enhancements of APIs, all of this to reduce our physical data center footprint. All these helped us achieve some of our goals to provide exceptional experiences to our clients, customers, and policyholders. We developed a blue-green deployment model, as so many of you would have tried, and the green model for all net new application and product developments, and blue deployment for our legacy data center-based applications. We targeted refactor and re-platform approaches for the applications in the data center, and we used containerization as a process for us to move into the cloud space using the managed EKS. And we did pilot trial outs with some of the applications by containerizing them and running them in the managed EKS space, and used that opportunity to really develop the deployment practices and enable some of the operational and management controls, security postures, guardrails, control procedures, tagging strategy for cost optimization, and above all, the developer access model. After a few pilots and lessons learned, we moved into the next phase of optimization phase, where we were able to really work on decreasing the build and the deployment time, increasing the deployment frequencies, and reducing the total cost of ownership, and providing agility and speed to market capabilities. With all these experiments, we are now in the scaling phase, where we are able to repeat these successfully established processes wide across the organization. So what's our cloud-first strategy do for us? As part of our cloud-first strategy, we set few standards that enable deliberate use and migrating to a cloud-based architecture, thereby reducing our reliance on data center-specific systems, increasing our infrastructure capabilities and software services. We chose AWS as our strategic cloud provider and started to make EKS as one of our prime factor to application migration and containerizing them and make it a bit feasible and easy for our developers. Our cloud-first strategy addresses all the critical needs of a customer shared responsibility model, including standardization and solving some of the security, risk, compliance, operational model, and governance frameworks, and above all, solving the cloud operating model, which I know a lot of you in the industry have trouble with. We solve some of those challenges by using the DevOps practices and cultures. With that, I do want to provide you some numbers to show the velocity and scale of our success story in the AWS space. Today, we host about 110 plus large EKS clusters and 100 plus business applications and utilities. We are planning to have a roadmap of migrating about 150 plus web services and API into the EKS platform or as serverless architecture framework. And why do we do all that? This is really to provide cost efficiencies and also, provide a more control in terms of our security framework, because customer shared responsibility model is one of the key factors we've been working on, and above all, reduce our total cost of ownership and provide all these cost benefits and efficiencies as dividends to our policyholders, because we are a mutual company. Thank you, Barry. Thank you.
It's always nice to hear from a customer. I would encourage all of you to make sure you're having those sort of conversations in the hallway. It's a great opportunity at reInvent to meet people who are solving the same problems as you, tackling the same challenges, and have ideas. So excellent of her to join us. She mentioned cost savings towards the end there. I think that is one of these big things that we should talk about as one of the areas that we've been focused on recently. And it's also kind of the elephant in the room in a lot of ways. There's a lot of pressure on companies today to reduce their spend. A lot of you probably came in with new goals and targets on spending reductions. How do I get more efficient, right? There's a lot of this theme kind of running around. In the old school world, you had customers over-provisioning on-prem just in case because you couldn't go like get a new server very quickly. And I think there's a lot of fear of it in the cloud. A sort of, are we over-provisioning? Are we spending too much? Could we do something a little bit closer and tighter? And I think the most important first step in that process is visibility. You can't optimize something you have no visibility into. So you want to be able to allocate across your team. You want to look at department levels. You want to have reports for the appropriate people who need to see them. Ultimately, you want to be able to do showback at least, let people understand the impact of the workloads they're running. Maybe you do chargeback if you're in a larger enterprise. How do you take this on? So for us, we've integrated with KubeCost. This gives you Kubernetes native style of cost basis. You get visibility into the costs inside a cluster in a Kubernetes way, by namespace, by pod, by groupings, right? It lets you kind of express this back to your clients, the cost of their Kubernetes workloads. So this gives you that first piece of really being able to say, this is the actual cost of the bottom line of what you're running. We do have integration with AWS cost and usage reporting, so you get accurate pricing regardless of your pricing model. It'll call in an update. It'll get your EDP if you have a special pricing agreement. And it has AWS Marketplace integration, so it's really easy for you to spin this up. We provide it free of cost, so there's no charge to EKS customers to leverage this technology and get a deeper view into what your cost structure actually looks like in a Kubernetes-friendly way. So now you understand how much things cost. Now the next step is how do I get that cost to come down? How do I make sure I'm only spending the money on the things I need to, and how can I optimize this? Once you've got that visibility, most people will find compute is their primary driver of cost. And in many cases, we're scaling in that back-end instance for you. You don't have to worry about it. You're trying to deal with your front-end instances, those nodes. How big do they need to be? What instances should I be running? And this is where Carpenter comes in. So Carpenter is open source. We started it in the community as a way for us to share back some of our thinking over the years working with enterprises on this problem. It lets you take full advantage of the cloud, all of those EC2 instance types. It's a clean way for you to actually go respond in seconds without you having to do the heavy lifting in a manual fashion. It helps you improve availability by reacting quickly and spinning up additional nodes if you need them. Cool, additional nodes, additional costs, not quite what I said, cost savings, right? So the other thing that we can also do is it will choose instance types to consolidate. It is smart about it, it understands the costing. And this can let you save significant money on your workloads as they're running in the system. So we do bin packing, kind of the whole set. You can restrict instance types. I could talk about this for a while. In fact, we have a deep dive presentation on it, but I think the best thing we can do for this is actually to go look at a demo. The best way to see this one is to look at it live, or as close to live as I can get away with in a reInvent presentation. So with that, I want to welcome Sheetal Joshi. She's a senior developer advocate on the team. She's going to walk us through Carpenter in action, give you a sense of what its capabilities actually are. Sheetal?
Thank you, Barry. I'm very excited to be here today to show you how Carpenter works and the cost efficiencies that you can achieve when you turn on the workload consolidation feature that we launched recently, and maximize those cost efficiencies when you work alongside the price-performant EC2 instance types. So I'm going to use an existing EKS cluster. As you can see, we already have a node that is running and in a ready state. I have configured all of the required cluster add-ons, such as Core DNS, kubeproxy, as well as the VPC CNI. You also see that Carpenter is already running on this cluster. Let's go ahead and take a look at the sample application that I'm going to use for today's demonstration. I'm calling this application as Inflate, and it is using the POS container. Nothing fancy here. It is just requesting for 250 millicores of CPU. Carpenter works with all of the resource type, including CPU, memory, and the GPUs. Just for simplicity of today's demonstration, I'm just using a single dimensional data, that is CPU. I'm going to go ahead and apply this to the cluster. To begin with, 0 replicas. We'll just soon scale it. So what you see on the screen here is the output of the tool that I'm going to be using for the demonstration. One of our own EKS engineer built this tool. Todd Neal, I'm very sorry you couldn't be here in the room today. So as you see here, as I scale this application up, the request goes to the Kubernetes API server. API server hands it off to the scheduler, and scheduler looks for the nodes, but no nodes are available before. The pods go into the pending state, and that's where the carpenter comes in, handles the pending pod events. It calculates all the resource requests, bin packs those pods, and makes EC2 Fleet API calls, and then provisions 5 of these 8x large instances at $1.20 per hour. The top line that you're seeing on the top section of the screen shows the total number of the nodes and the total CPU used by all of the pods and the total number of the CPUs available across all of the nodes and the percentage of CPU across all of the nodes as well. More importantly, what you see here is the cluster cost, which is $4,400 per month at an average rate of $6 per hour. So let's go ahead and see what happens when I scale down this application. So I'm going to go ahead and scale it down. As you can see, the Kubernetes goes ahead and deletes those pods. But as you see here, there has not been a major change to the number of the nodes. And also you will see these nodes are left underutilized. And absolutely no changes to the cost of the cluster. It is constant at $4,400 per month. And that's where the powerful feature of Carpenter, which is called workload consolidation, comes into picture. So before I move on to showing how consolidation works, let's take a step back and see how Carpenter makes this all happen. What you're seeing here on the screen is a snippet of the provisioner. So provisioner is the main CRD, and when you install Carpenter, you also configure a provisioner. Amazon EKS officially supports AWS provider. Carpenter also provides the APIs and the specification that you can extend to implement your own provider as well. That can work with other cloud providers. You can specify an ARMY family in here and also specify a specific ARMY ID. You can bring in your own custom ARMYs and any custom user data or the launch templates that you want to use with. And here I'm saying, Carpenter, use the subnets that are tagged with EKS demo to deploy nodes to, and then applies the security group which is tagged as EKS demo. The parameters under the requirement section influences the decision that Carpenter makes with the instance type selection. Carpenter supports well-known Kubernetes labels such as architecture and the zone that you're seeing here. It also adds some of its own such as capacity type, which can work across different cloud providers, and some which are very specific to AWS, such as instance CPU. And what I'm telling Carpenter is, you cannot provision any nodes which have more than 33 CPU cores. You also do not want Carpenter to be eating up all of the resources in your account, especially if you are supporting multi-tenant environments. And that's where limits come into play. And here I'm saying this provisioner can only handle up to 5,000 CPU cores and not beyond that. And the sample application that we saw did not require any special hardware or the acceleration. That's where everything is set to 0. By default, workload consolidation is turned off. I'm going to go ahead and enable the consolidation. I'm going to go ahead and apply this provisioner to the cluster. And when consolidation is enabled, Carpenter actively works to reduce the cluster cost by identifying when nodes can be removed because the existing pods can be rebalanced across the existing nodes. As you can see here, the cluster cost went down a bit. Let's go ahead and scale down the application and let's see what happens. So when that scale down event has finished, you are left with a cluster cost of $3,100. So what happened was it removed the high pricey node, and then Carpenter decides I can run the remaining nodes on to the cheaper instance, which costs 60 cents versus $1.20. And at the end of it, when the consolidation is all finished, the cluster cost dropped down to $3,100, almost a 30% drop in the cluster cost. This is great, but can we do better? Of course. So we can actually integrate with the price-performant EC2 instance types, such as Graviton. Graviton processors are custom built on 64-bit ARM Neoverse cores, and they provide 40% cost efficiencies. So let's go ahead and add Graviton to the mix. And also, Graviton instances are 10 to 20% cheaper than alternatives in the same instance family. There are many ways that you can enable Graviton, but in here, I just took a simple route and added ARM64 to the OS type. I'm going to go ahead and apply it to the cluster. As soon as we apply that ARM to the provisioner and Carpenter sees the change, consolidation kicks in. It goes ahead and cordons the node which runs the least amount of the pod. Carpenter always uses the least disruptive policy so that your application continues to run while honoring all of the pod disruption budgets in the place. What you're seeing here is Carpenter gonna go ahead and replace node by node, and it usually takes a minute for Carpenter to provision the new node. So let's give it few seconds for the consolidation to complete. Yeah, as you can see, 2 nodes are complete, and it's gonna go ahead and, if the Graviton capacity is available, it's gonna go ahead and replace all of those nodes. One important thing to note while this is happening, for this to work, you have to make sure that your applications run on multiple architecture, and the container images that you're gonna build can run on multiple architectures as well. As you can see, all of the nodes have been replaced with the Graviton instance, and your cluster cost is down to $2,700, which is like a 40% drop in the cluster cost. The last thing, I know the top question on everybody's mind, Spot. Yes, of course, Carpenter natively integrates with the Spot by implementing all of the Spot best practices. Let's go ahead and add Spot to the provisioner. So I'm gonna go ahead and update Spot to the capacity type and apply change to the cluster. So as soon as Carpenter sees Spot added to the provisioner, consolidation kicks in again, and it looks for the available Spot capacity. As you can see here, it found available capacity for Spot and replaced on-demand instance with a very cheaper 25-cent Spot instances to begin with. And you can see the second one is at 54 cents. And the consolidation can stop here by giving you a 50% cost savings. And in extreme cases, that can be all of your instances running can be replaced with the Spot. In reality, Carpenter will attempt to provision on-demand capacity if there is no Spot capacity available. The best defense against running out of the Spot capacity is to configure more instance type in your provisioner. Plus, carefully examine your workloads. You do not want to be using Spot if you are running long-running batch jobs. What can happen when the Spot termination happens? You might have to restart your batch job, wherein you will end up paying more for your compute capacity versus paying less. Carpenter support multiple provisioners, and in that case, we recommend that you configure a different provisioner to isolate your batch jobs to be running on on-demand capacity type versus the Spot. We just saw how by deeply integrating with Amazon EKS and EC2, Carpenter lets you achieve those cost efficiencies which would have been impossible doing so manually. We started off cluster cost at $4,400, and when we enable the workload consolidation, the workload cluster cost actually dropped down by 30%. And finally, when we added Spot, and as in the extreme space, the cluster cost actually dropped down to $1,300, giving you a 70% drop in the cluster cost. I want to end this demo by saying Carpenter is powerful, very efficient, and highly effective. It all depends on the flexibility that you provide Carpenter with the instance selection, topology spread, and the pod placement strategies. And finally, and more importantly, you should design your applications to be resilient, to take the complete benefits of Carpenter and the workload consolidation feature. I want to send a big round of applause to Todd Neal, who built that tool, as well as the entire Carpenter team who made this demo possible today. Thank you very much. Now, back to you, Barry.
Thank you. All right, that was very cool. Cool use of VI, too, for those of you who are old school like me. So what else have we been up to? So one of the things that we've been trying to do is to really extend access to AWS. So if we look at a few of the areas that we've been doing this, I talked earlier about access to AWS services. ACK has been out in the field here for a little while. It's another open source effort of our part. The idea being that we want to harness AWS resources directly inside of your cluster. In other words, you want to be able to do things in more of a Kubernetes native way. ACK has a whole host of different components that are now available or upcoming soon. Again, this is all done in open source. You can see the GitHub location down below and take a look. But this gives you a really nice Kubernetes native way to launch AWS services inside of your clusters and can be a great way for teams to take advantage of the power of AWS. Another area, we talked about those higher level services earlier. AWS Batch is a great example. There's a lot of these kind of data intensive workloads that have been coming onto EKS. We just recently launched batch support for EKS. This gives you a fully managed batch computing solution that is EKS cluster aware. It is compatible. It will segregate workloads from your batch side outside of other clusters that you may have running in EKS. So this is a really powerful solution for a lot of different use cases. There's quite a bit in the genomics or drug discovery, ML training algorithms, there's a host of different places where taking advantage of AWS Batch on an EKS set of clusters can be a really valuable tool. Other things we've been doing, partner software. One of the things that I often tell people is the Kubernetes team at AWS is ridiculously partner friendly. Any of you who've met with me who are partners probably know that. If you're launching a cluster, it takes more than just your software to run a production cluster. There's a host of other things that you want to have in that cluster that you want to be able to take advantage of in that cluster. Monitoring, security tools, we talked about KubeCost as cost management, just a few of the examples. So what have we been up to? We wanted to bring some of the EKS add-on style of easy deployment to clusters, but take it into the AWS marketplace, expose it to the full partner ecosystem. And that's what we've done. So now vendor-provided tools that are a part of the AWS marketplace can be accessible inside of EKS through the EKS APIs, inside of EKS console. So it makes it a much easier, seamless experience to take full advantage of our partner software suite. You also have awareness from a versioning and Kubernetes perspective. You'll only see things filtered down to the version of Kubernetes that you're running is supported by that version of partner software to let you then deploy it. So it gives you a nice, clean experience on that front. Today, our launch partners are on the left, KubeCost, Teleport, FactorHouse, Tetrate, Dynatrace, Upbound. We have a whole host of other partners actively working to launch within the next 60 to 90 days, and a whole host of people behind that looking to get on board. Our goal, make it easier for you to get the workloads and the software necessary in your clusters right out of the gates. So, if you looked at the title of the talk, I talked about Kubernetes for everyone. I know what a lot of you are thinking, that's cap, right? But let's be real. Let's constrain the problem a little bit, right? My grandma's not gonna be running Kubernetes. I'll be honest. She's been dead for over a decade. That's part of the problem. But even when she was around, knitting was her thing, not technology. So clearly, when we say everyone, we want to get this more accessible to people who do not have large software operations teams. We want to make Kubernetes easier for people to consume out of the gates. So our focus areas, we continue to focus on the community. We think it's incredibly important. From a technology perspective, best practices. This is a common ask for us. How do we give you operational best practices? How do we drive that global availability and hybrid support? We continue to make investments in these key areas as we're evolving the product. When you're looking to manage Kubernetes at scale, you want more smaller clusters. right? For lots of very good reasons. You're reducing your own blast radius. You have better security isolation in these kinds of models, right? But what's key is automations and standards, right? Once you have 10,000 clusters running, you don't want to be the person hands at the keyboard trying to figure out what's going on, right? You want more automation in this. We have the fully managed control plane. We talked about that. We have managed compute today. We talked about Carpenter. We have managed nodes, right? We have Fargate for those who are going down the serverless path. Lots of operational tooling available. We just talked about the enhancements in the add-on space to make that even easier, to give you as much choice as possible. Single pane of glass, that EKS console, give it a Kubernetes cluster to go look at. It'll share you information about what's the state of that cluster. What do we want to be able to do? We really want to simplify actions for folks. We want to be able to say, hey, take this action on all clusters with this tag, right? Or this group of applications. We want to have opinionated templates. Somebody was pointing out to me yesterday that aren't all templates opinionated by definition, and I said, yes, but I can't edit my slides. You can edit your template. Take our opinion, throw it out. Take our opinion, keep half of it, change the other half, right? That's kind of the point with these things. It's just an easy way to get teams started. Reconciling deployments. One of the great things we talked about from Kubernetes perspective in general was this idea that it reconciles continuously. Wouldn't it be great if your deployments also were able to do these things? And improving monitoring and troubleshooting. One of the common asks that we've gotten is, can you please expose a little bit more visibility into what you're doing behind the curtain, right? I don't need all the magic, but I'd like to kind of see where you're at so that I know what the workload balancing is looking like on your side of that spectrum, right? Common ask for us. So we've talked about all kinds of different things, but how do you actually get started if you're early in this journey? I figured it's a good way to finish. How much help you need can be a very broad spectrum, and we have a very broad spectrum of possibilities. One that's relatively new is our open source technical field community. It's a large collection of AWS experts with expertise in OSS software and in Kubernetes on OSS software. If you're needing some advice, you're wanting to talk about which pieces have different trade-offs, this is a great community for you to engage with to get some of that information. Let's assume for the moment you need a little bit more direct guidance than that. EKS blueprints. So this is infrastructure as code, Terraform, AWS CDK. It's that opinionated template, right, to some extent. It is based on best practices. It's the most common question we get is, how do you recommend I deploy it if I'm trying to do something like this? That's what Blueprints is all about. It is open source so that you can go and find it. You can take that template and modify it to your heart's content and customize as needed. Data on EKS. I've talked a couple of different times about this heavy, intense use of data workloads. So we're launching this in early 2023, but similar to Blueprints, how do you give me some templates, some best practices if I need to do something like Spark on EKS? So what are some of the templates, the components, best practices that we see through our experience working with lots and lots of different customers to be able to take advantage of data-intensive workloads in EKS clusters? Now let's assume you want to go even deeper and you actually want somebody to help. Like, I need to sit down with somebody and I need to work through my problem space. AWS Data Lab for Containers is a free service that we offer. This will let you go sit down with experts who will help you kind of get the ball really rolling. Get yourself to a POC. Go remove some of those obstacles, some of those first challenges that you might be facing as you're trying to deploy new workloads, trying to ramp up new organizations, targeting a new piece of technology. Data Lab's a great way to do it. Come with an idea, leave with a solution. Cool tagline. Great way to get started and free. Now there's other people who are in the enterprise that don't even have software development teams. They need a little bit more help, right? And so AWS has a full range of capabilities in the professional services area. They can actually offload your teams if you have some work you'd like somebody else to take on. We have technology partners who can help with third-party software components that you can leverage outside of just like the open source stuff we've been talking about. And we have AWS consulting partners. We can put you in touch with other third parties who specialize in consulting in areas that are familiar to you. Maybe you need someone in the telco space. Maybe you need somebody who's really done a lot of work in the financial services space, and we have those connections, and we're more than happy to take those on, help you get started, connect you with the right people. So those are a few of the things that we have to kind of help people get started. I thought it would be good to come full circle. I found this one I did find, just to be fair, and it was a straight up old school search. But hopefully we've clarified a little bit of the journey, shown you a little bit of the path, We are thrilled to have so many of you interested in Kubernetes at AWS. I want to thank you all for your time and enjoy the rest of reInvent.